Man, what's going on, my ASVAB party people? Anderson here, your ASVAB coach, and we've got a nice treat for you on this Saturday. As always, we've got a 2-hour class recording on solving equations, word problems. But here's the main thing. Have you ever done a word problem where you're having trouble understanding how to translate the English that you see into the math that you need to actually solve? Yeah, that's a main issue that a lot of people face. And so in this video is a recording where we walk through a ton of different problems where we understand, hey, look, this is not just about being able to look at a problem and know how to do it. This is about having the ability and the skill to translate the English into math. That way, when you do those tougher questions, the ones that are just a little bit out of your range, you'll still be able to understand how to translate that English into math so you can solve the equation no matter what the situation is. And so go ahead and enjoy. And as always, if you didn't know already, we have a full-on program where you can get all of the classes, all of the recordings, my support every single step of the way. You get practice problems with video solutions to help you build that confidence and trust that you're building that skill set. And so if you want to learn more about my full ASVAB All Access program, that's my phone number right there. Go ahead and text me, say, hey coach, my name is so-and-so, found you on YouTube and I'm interested in the All Access program. And I'll go ahead and walk you through how it all works. That way you can raise your score nice and easy. But as always, I'm Anderson again, your ASVAB coach. Let's go ahead and get started here, learn how to solve equations, but more importantly again, how to set them up. Let's get to it and I'll see you on the other side. Let's ace the ASVAB. What we're going to be doing today, again, everybody, today's topic, setting up equations. So again, translating English into math, all right? Translating that English into math. So first off, we got to know these keywords, okay? So these are just some, and I mean some, not all, just some of the keywords that we're going to be using. So if you'd like to take a screenshot of this, please do. But we need to really focus on the multiplication and division aspect of things here, because multiplication and division, this is it's gonna be pretty interchangeable. I'm not gonna lie. Now, the word per is something that I really want to focus on today. The word per. You see it here in division, but I'm gonna be very real with you, very honest. It can also mean multiplication. So for example, everybody, think of it like this. If you say that, oh man, Johnny is charging $2 per Kit Kat bar. There's 10 Kit Kat bars. If it's $2 per Kit Kat bar, and we got 10 Kit Kat bars, everybody, what are we gonna do with the $2 per Kit Kat bar and the 10 Kit Kat bars? What are we gonna do? Multiply it. Parmita says multiply it. Do we agree with that? We got another person agreeing. Yeah. In that situation, we would. Exactly. But let me go ahead, pause right there. Let's flip the script. Let's flip it for a second. Let's go ahead and say that, yo, Parmita, I'm going to use it as an example right now. Parmita made $20 today selling Kit Kat bars. She made 20 bucks. She sold the Kit Kat bars at $2 per Kit Kat bar. How many Kit Kat bars did she sell? Everybody, in that case, what do we need to do here? Before we multiply, but here we would divide, right? Because you see that we're going from the result back to the piece, not from the pieces to the total result. So that's why I want to make sure that I'm prefacing all of this by saying, yo, when it comes to multiplication and division, it may seem confusing in terms of what the terminology is telling you to do. And that's what we're here to work on today. I'm going to make sure that we're going to be in a good spot, but I want to forewarn you now about these. That way we can feel good about ourselves later and we can actually be good. So with that said, they always had a trick up their sleeves. They always do. That's okay. It's all good. So with that, hopefully you got a chance to go ahead and take a screenshot here. But some of the more common terms that you're going to hear or keywords for addition. Let's just go through them real quick. When you see the word sum, that's basically addition. Yes. When you see plus, total, together, added, combined, more than, Depending on the situation, like if you're not talking about amounts, but you're talking about age, older than, that still means more. That still means on top of or addition to. Farther than, consecutive, greater than, increased by, all of those denote addition. So looking at subtraction, anybody ever see problems that ask how much peanut butter is left or how many of blank are left? That always tells you subtraction every single time. Every single time. When you see the word altogether, that's, hey, finding the total, finding the sum. And so I always want to have you guys imagine what's going on with this situation to understand what keywords we're actually supposed to be looking at. So here, less, minus, less than, difference, fewer than, smaller than, younger than, again, depending on what kind of numbers we're talking about, whether it's money or age or distance, right? Decreased by, diminished by, subtracted from, all of these keywords talk about subtraction. So again, it's pretty clear cut between addition and subtraction. It's very clear, very clear. But when we are talking about multiplication and division, when it comes to these words, specifically these words, the word per, each, equal pieces, those are interchangeable. Honestly, those are honestly interchangeable. It really depends on the situation, but I'm going to show you how you can always pick one of them and be fine. You can always pick one. If you want to always use multiplication, which is the easier way, I'm going to show you how to set these problems up using multiplication always. That way you can stick to one and never be confused. But with that said, I got y'all, man. I got y'all. Let's go ahead and go to the next slide here. I gave you guys plenty of time to see that. If you're just coming in right now, I'm going to count to 5 seconds to give you time to screenshot this. All right, so hopefully you are ready. Sounds good. So let's go ahead and move forward here. Word problems. Anybody here nervous about word problems? Yes or no? Who here is nervous about word problems? Be honest. All right, May and her other two personalities all saying yes. Sounds good. All right, so you know me, guys. For the first half hour or for the next half hour until 7 o'clock, we're going to be working on the fundamental problems, those basic ones, okay? That way I can warm you up. And then in the last hour of class, we are going to kick it up a little bit and get into those more complicated problems. So again, if you feel like you're more of an advanced student yourself, you know the advanced problems will be coming up. If you are nervous and feeling like you need the basics, well, then that's why we're here, okay? So there are three steps to success here when it comes to setting up equations or translating that English into math. First things first, this never changes. Start by reading the question. You want to know what you're looking for every single time. Every single time. You always want to understand what it is you're looking for. Think about it, everybody. How are you supposed to have fun playing a game when you don't know what you're supposed to do to win? Right? How are you supposed to have fun playing a game if nobody tells you how to win? So that's step number one. How is it that I'm supposed to win this game? Read the question. That's step number one. Step number two. This is where you are going to put the pieces together. You have to make sure you understand how what you're supposed to find is related to what the problem gives you. Building this connection is the hardest part. The easiest part, honestly, for me, reading the question. It tells you exactly what you're supposed to find. Cool. But when it comes to making a connection between the information that's given to represent what you're supposed to find, that's something that I know a lot of people have trouble with, and this is what we're going to go over heavily today. And I mean heavily. So this is the main focus of today. Main focus of today. And for those of you guys coming in just a little later, welcome in. My name's Coach Anderson. So yesterday we did a class on solving equations, just straight up solving them. We did it for 2 hours. Today, we are going to be working on the word problems and actually setting up these equations, okay? We're not going to be focusing too much on solving them. It's mostly going to be setting them up. So just giving you a fair warning here. So step 3, this is something that a lot of people don't do. Anybody here ever actually get an equation set up and then you just say, I hope this works, and then you just solve it and move on? How many times have you ever done that before? I have. I know I have. Yeah. Yeah. Like, sometimes, if you get nervous, especially with a timer, sometimes you're just like, man, screw it. The answer's there somewhere and you just go for it. But the thing is, if you practice making sure that equation makes sense in terms of the story, you're going to find that you're going to be so much more confident when the equation makes sense. If it makes sense to you, oh man, I can tell you right now, you're going to be so much more confident when you're solving it. And so we're going to practice that a little bit today for sure. But again, setting it up is the main key. So we're naturally going to be doing it. So it's the variable that gets you. I got OCD on labeling them with the story. And that's okay, Alex. You're supposed to be doing that. So lastly here, I want to show you guys that being in my program is awesome because everybody, solving equations is the art of what? Justin first, Parmeet second. Everybody write it out. Go ahead. Play copycat. What are they saying right there? Working backwards. That's right. Solving equations is the art of working backwards. And that's something that we're going to be focusing on as well. But again, not too much. Not too much. It's more so setting it up, but I got to remind you all from yesterday. All right. So here is a picture of me. I'm beautiful. All right, so let's go ahead and move on here. Let's start off with a practice question. All right, Stephanie paid $5 for a pizza. Alex, I'm going to make that an NFT and I'll sell it to you. So Stephanie paid $5 for a pizza. Everybody, what am I doing wrong? Already, what am I doing wrong? Yeah, I got to read the question. And Kamaya, let me know if you have a question or let me know if you just forgot to put your hand down. I think you raised your hand when I asked a question earlier. So just let me know if it's a question and okay, cool. So we got to read the question first. Remember, I don't care how long the problem is. I really do not care if you care at all or not. The best way to start a problem is to say, hey, before I open up this huge old book of notes, before I start doing this with the problem, just read the cover of the book. What is this book about? This book right here, this problem that we're looking at is about, right here, how much money did she have before buying the pizza? Okay, sounds good. How much money did we have before buying the pizza? Sounds good. So, how much money before buying the pizza? All right, so sounds good. Step 1, we want the money before buying the pizza. Now, I don't want you to write this all down, during the test. Obviously, we want to write less, but as you practice, this is absolutely okay. Now, this is what we're going to do next. We're going to read through the information and then see how we can use that information to get us to what we originally had. So, with that said, what do we see? We see Stephanie paid $5 for the pizza. Okay, so step 2, let's write down this information and see what we can do. So paid $5 for pizza. Okay, so everybody, let's tell a story. And I know this is going to seem very, 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 very easy because this is a very fundamental problem, once we actually lay it out. But I want you to practice writing out the equation, even if it's this easy. Because if you can do it here, then you can do it with the next set of harder problems. So, everybody, question. What variable should I use for what we're looking for? The money before buying the pizza. What should we use for that? P for pizza. X. I'm going to go with M. I'm going to go with M just to kind of follow the story here just a little bit. I'm going to say M because we're talking about money. How much money did I have before buying the pizza? So everybody, if we start with the money, again, what we're looking for, if we paid $5, what happens to that money that we had? What happens to it? Poof, gone, right? You take that away. So again, I'm just trying to make sense of the English into math. And I know a lot of us here are saying, yo, this is very straightforward. I know. But trust me, we're going to get more and more harder. It's going to get more harder. It's going to get harder. I don't know why I'm saying more harder. But yeah, so here we are going to take away the $5 because that was the pizza. Then everybody, what did we end up with here? We ended up with $12 right there. Yep. We ended up with 12. Now has $12. And you know this is going to be on the other side of the equal sign because it says now you have 12. So just ask yourselves real quick, everybody. If we just go ahead and replace the English with math, can everybody here see how we can turn this into m minus 5 equals 12? Can everybody see how we got there? The money we had in the beginning, after we paid for the pizza, so you have to take away $5 from what we have, we ended up with 12. And so all we need to do now is solve this equation and we're all done. This is like the really formal way of thinking about it, obviously. Is this unnecessary to a degree? Absolutely. But I'm doing this to prove a point to show you how to solve these. So just remind me from yesterday, working backwards, what are we supposed to do to both sides? What are we supposed to do? Mario says add 5, add 5, add 5. Yes, yes, and yes. We're trying to get the m by itself. So I'm going to add that 5 to get the m by itself. That's gone. And we simply end up with m equals 17. $17, and we're right there. So again, we're starting off again with these fundamental questions, but you're going to notice how this is going to help us moving forward. I promise you it will. I promise you it will. Another way that you could have solved this would have been quite easily, well, if you end up with 12, after spending 5, just take the 5 back, bring the $5 back. That's 17, we're done. But that's exactly what we did. You start with the 12, you add the $5 back, you end up with $17. It's the same exact thing, just presented in 2 different ways. That's all it was. That's all it was. So everybody good for me to move on to the next one? Because this next one is still a basic one. Then after that, we're kicking it into high gear. All right. Any no's, any questions? All right, let's go. So next one here. So here we go. So Deshaun wants to buy a problem, everybody. What am I doing wrong? Read the question. That's right. I have to read the question first, as always. Don't get lazy. So here we go. The question reads, what is his change? What is his change? So let's be real, everybody. Let's be realistic. Let's go ahead and say C equals, the change received. All right. So this is what I'm saying when it comes to word problems. With these more basic questions, you'll be able to do these pretty quickly. I know this. Now, everybody, just ask yourselves, how do you typically receive change? What do you have to do to receive change for anything? Parmita, great. Change is the leftovers, right? It's what you have left after you spend. It's what you have left after you spend. So what does it sound like we might be seeing in this problem? What kind of math operation should we see? Right. We should definitely be seeing subtraction. Because remember, change is what's left. So, okay, I can definitely hope to see some subtraction here. Let's read the problem now. The problem reads, Deshaun wants to buy a microscope for $79. So buy for $79. It gives the cashier a $100 bill. So it looks like the change that we're going to receive, if it's okay with y'all, if we start off with $100, if we are spending 79, we should be subtracting the 79 for the microscope. And that's how you receive your change. So everybody, does this story make sense? Does this story make sense? You start with $100, you spend $79, and what's left is the change. So what's left is after you subtract, that's what you have. And boom. So now all we have to do is translate this into pure math, solve it, and we're done. This makes sense in English. Let's make it make sense in math. So 100 minus 79 equals your change. And that's it right there. And if you know your mental math, you can climb up from 79 to 100 by just saying, hey, you can get to 80 if you add 1, and then 100 if you add 20. So 21 is going to be your answer. A. And so just a quick bit of mental math right there. If you think that subtraction is only subtraction, no. Subtraction is the opposite of addition. So you can literally start with the ending number and climb up to the original. So 79 plus 1 is 80, plus 20 is 100, 21. Done. That's just a little bit of mental math that you can use anytime you do subtraction. It works every time. So with that said, everybody here good? We can move on to the complicated one now. All right, y'all asked for it. Y'all asked for it. Where are my glasses at? I want to be a fool today, but I can't. I just cleaned out my whole office, so now I can't find anything. All right, life of an ADHD man. Here we go. Up next. Here we go. Oh, what's up, Joe Marie? No worries, Joe Marie. Let me know if you have any questions. All right, so at a restaurant, Aaliyah and her 8 friends. Everybody, what am I doing wrong, man? Well, first thing I did wrong was clean my office. But what's the second thing I just did wrong? Yeah, we got to read the dang question. That's right. Thanks for scolding me. Who was that? Parmita. Read the question, damn it. All right, yeah, exactly. We got to read the question first, man, every time. So here, what was the total bill? Right there. What was the total bill? Notice how I didn't actually read this first part here, because that's not the question. The question is starting with who, what, when, where, why, how many, which of the following. Those are the action words that identify the question. If they say if, that's just giving you information. So basically saying like, if the sun is up, what am I doing today? The question is, what am I doing today? A condition, information, is the sun is up. So I want you guys to really understand the difference between information and proposition or question. So there's a big, big, big difference. Okay, big difference. So what was the total bill? That's what we're looking for first. Total bill, and we can say that equals T. Okay, that's T. Just to make things easy. Now, we're taking a look here. We're going to start reading the information. Let's see what we got. Let's see what we got. So we see that at a restaurant, Aaliyah and her 8 friends divide the bill evenly. Each person paid 20. Okay. So this is where reading is really important, being very attentive to details. I know some of us here are thinking that the answer is 160. Yes or no? Who here has 160? Everybody else shut up. Who here thinks that the answer is 160? I got a couple of people direct messaging me saying, not anymore. So no, look, we got to make sure we pay attention to what the information's saying. So it's all good. If it says Aaliyah and 8 friends, how many people is that, everybody? If it's Aaliyah and her 8 friends, how many people is that? That's 9 folks, right? That's 9 friends. That's 9 people. That's 9 people. And then it says each person paid 20. So each person paid 20. So here's the key word we're looking at, everybody. The word each, okay? You can use it as a multiplication or division. The word per, each, for every, literally can be used as multiplication or division, depending on what direction you're going, forward or backwards. If you're going forward to get the total, you're multiplying. If you're going backwards to get one of the pieces, you're dividing. So everybody, let's make life easy for ourselves. If we're trying to get to the total, will we be multiplying or dividing? What did I just say? If we're trying to get to the results, we would be multiplying going forward. If we're trying to work backwards, we would be dividing. And I'm going to show you what that looks like. All right. I'm going to show you what that looks like. So essentially here, everybody, if we have 9 people times $20 per person, that's going to give us the total bill. I think we can think about that in a restaurant, right? $20 a person, 9 people, multiply them. We're going to have ourselves $180. Not 160. All right, not 160. It's going to be B. It's going to be B. Now, we can use this to work backwards as well. So just a quick detour. I want to show everybody how you can set this up using division with that word each. So I'm going to write this off first because I want you to write this down. Again, each, per, for every. I'm going to show you here. So it's multiplication or division. So if you want to use multiplication for the word for each, or no, for every, for per, each, here's what you're going to see. You will multiply to get to the results. You multiply to get the grand total, the result here, okay? Now, when it comes to division, you divide to get a piece. So in this example, I'm going to show you what that looks like again. I'm going to show you what that looks like. In this example, we can multiply to get the total. So that's where it was 9 people. Let me use something really skinny here. 9 people times 20 per person equals $180 total. That's working forward. Now, working backwards, if using division, you would say, hey, you would go with something like this. I'm going to use red to go backwards here. So let me just zoom in just a little bit, and I'll go back up if anybody needs me to. I got you. But we can say $180 divided by 20 per person equals 9 people. So notice, the 9 people is not the grand total of the whole situation. The grand total of the whole situation is the total bill. It's the total bill. Because I think we can notice that the people times the amount per person is what gives you the total. But if you wanted to work backwards with the word per or for every or each, then you would start with the total, divide it by that thing with the per to get a piece. Just how many people were there, the number of people involved. So yes or no, everybody, is this making a little bit of sense here in terms of, hey, how we can use per to multiply to get to the result, how we can use per to start from the result to get to the beginning, whether it's finding the number of people or that. Okay, so again, I want you guys to start seeing it just a little bit. And if you're still confused on that, don't worry. We are going to see plenty more examples with the word per in here. Trust me, we will. We will. But I want to make sure that I introduce this idea because it is interchangeable. The word per and each and for every is interchangeable. So I'll give you guys a second to take a screenshot here if you need to. Let me get my face out of the way. That way you can take a screenshot of what's behind me. So feel free to take a picture there. 3, 2, and 1. So remember, if you're in the program, this recording's going to be up first thing in the morning. And one thing that I've noticed, has anybody had an issue with the blurring with the recordings? Has anybody had the recordings be blurry for them? Okay, cool. So I'm going to fix that up. One thing I'm going to start doing now is I'm going to start recording the classes straight to my computer. Right now it's streaming to the cloud, to the Zoom cloud, but I'm going to go and stop doing that. I already bought a hard drive and I'm going to start recording them straight to my computer. That way it's much better quality. So I got y'all. No worries. So here we go. Two-stepper now. So this is where we're getting into the more complicated type questions here. So here we go. How much did each pencil cost? How much did each pencil cost? All right, no worries, Floyd. Appreciate that. So here we are. How much did each pencil cost? And also, a quick detour. If you're using your phone, make sure to turn your phone sideways. It'll help you see more of the screen because I know this can seem a little small. So just make sure to turn your phone sideways. So with that, how much did each pencil cost? Everybody, we're trying to find the cost of each pencil. What is a key word in that highlighted text there? What's a key word that might indicate what operation we're doing? Each. Exactly. We just got done talking about it, right? We just spent 5 minutes talking about the word each, per, for every. We got to make sure we know what we're doing here. So step one, our question here is that we're trying to find the cost of each pencil. And so I'm going to call that C, the cost for each pencil. C for cost. There you go. So C for cost. All right. Sounds good. Cool. Big whoop. What do we do next? So what we're going to do next is we're going to stay calm, cool, and collected. And we're going to just collect our information. Knowing that, again, the word each tells us that we could be multiplying or dividing. We don't know. It really depends on what direction we want to go. It's up to us. It's up to us. So it says here, collecting the information to create the equation. You had $23 to spend. So everybody, the $23, how can we kind of simplify it and categorize it generally? Is that like the beginning amount? Is that the result? Is that the what? Like what is this? ARAM, that's perfectly stated, but let's go ahead and keep, you guys are advanced. I love that. That's the beginning amount, exactly. So I'm going to say here, we start with 23 bucks. And then what did we say here? It says that we bought 6 pencils. Okay. We bought 6 pencils. And everybody, how much did each pencil cost? How much did each pencil cost? Don't give me a number. I'm not looking for a number. How much does each pencil cost? That's right, Stefan. We don't know. We don't know how much each pencil costs. But how did we label it in the beginning of the problem? Hint, hint. Hint, hint. What did we label? Yeah, C. My eyes hurt now. C. I gotta get my eyes checked. All right, so C. We used C. All right. 6 pencils at C dollars per pencil. Again, do I know the exact number? It doesn't matter right now. We are going to figure that out. So I know some of us were able to work backwards instinctively here, which is awesome. But if you don't learn how to set up equations, I'm telling you right now, all I got to do is switch up the wording and I can screw you up. And I don't want it to happen So I need you to focus up. Even if you know what the answer is and you're like, yeah, we're good, I know this. Trust me. I know how good some of y'all are instinctively, but let's turn that instinct into knowledge and strategy, okay? So we bought 6 pencils at C dollars per pencil. And then we ended with, let me use a different color here. We ended with, after buying, you have $5. So the result, you end up with $5. So let's go ahead and think of it like this. If we start off with 23 bucks, everybody, when you buy those 6 pencils at C dollars per pencil, or when we purchase, when we buy and we spend money, what operation is that? When we purchase something and spend money, what are we doing? Are we gaining money? Are we losing money? Are we dividing our money? Are we multiplying our money? What's happening here? Right, we're losing money, and losing is connected to what operation? Subtraction. Right on, guys. There we go. There we go. Yep, we are losing money, so we are subtracting. So minus, again, spend. This is how we started. We spend money. And how much money did we spend? Well, I'm going to go ahead and just show you right away, but I'm going to show you why. Everybody, the word per, what operations could that mean? Which 2 operations could that mean, the word per? Remind me again, pop quiz. Multiply or divide, right? Multiply or divide. So if we want to subtract the money that we spent on the pencils, should we multiply to find that amount or divide to get that amount? If we're trying to find out the total money that we spent, hint, total money that we spent, are we multiplying or dividing? Nah, not division. If you're getting to the result, remember, if you're getting to the result, you will multiply. So think of it like this, everybody. 6 pencils at C per pencil. No matter how many pencils or how much money you spend, you're going to multiply to find that total. So for example, just think of it like this. If you bought 6 pencils at, let's say, $10 a pencil, let's say you're at the Versace of pencil stores, okay? So you have 6 pencils at $10 a pencil. Okay, cool. Pencil 1, $10. The second, now you spent 20. The third pencil, 30. Oh, 6 pencils, 6 times 10 to get 60, the total amount that you're going to spend. So everybody, does that make sense there in terms of, again, if you're trying to see how much you spent, we will write 6C because this is the total spent on pencils. To find out how much you spend total on those pencils, you're multiplying the amount of pencils and the cost per pencil to get that total spent. And that's 6C. And then from there, what was the result? What did we end up with? We ended up with $5 right there. We ended with 5. And so let me not make this messy. Let me just make this a little cleaner because I do want to make sure that y'all appreciate, just the order in which we do this. Yeah, I got you. Carrie Ann. But from here, I want to make sure that this makes sense, you guys. I want to make sure that the setup of the equation makes sense. Yes or no? Okay, cool. Cool. So that's one way we can see it, okay? That's one way we can see it. Now, we get the 5, Alvin, because we ended up with $5. So think of it like this. You walk into the store with 23 bucks. You spent your money on the pencils. You ended up with, it equals $5. So you start with 23. You spent all this money on the pencils, and that's going to be 6 times C. 6 pencils times the cost per pencil. And you end up with $5 right there. And so again, you have to make sure that you're working on your ability to translate the story from English into math. Are there other ways to solve this problem? Absolutely. Half of y'all solved this in your head. Half of y'all solved this in your head. It was awesome. So the point here is not trying to show you one and only way. I am trying to show you a general way that will work for every single problem that you do. That way you don't have to rely on instinct and hope that the problem just intuitively makes sense, but you can actually take any problem and represent it with an equation, whether or not we're talking about pencils, hydraulic presses, which I know a lot of y'all don't know about, talking about rockets, talking about fuel coefficients. You can be talking about anything. If you can translate the keywords into math, it doesn't matter what the problem's about, you'll be fine. Everybody, do you see the point I'm trying to make here? Yes or no? And we're going to solve it. Don't worry. We're going to solve it. But I really want to make sure that you understand my point here, because again, I'm not trying to have you all rely on your instinct too much. I want you to rely on strategy and know-how. So with that said, here we go. The question of today is, Coach, how do you solve it? I got you. I'm going to solve it, but trust me, we're not going to solve every equation in this class, but I will solve this one for you. So here we go. Let me just rewrite it real quick. 23 minus 6c equals 5. So everybody, the point of solving equations, the strategy is, it's the art of working backwards. I've said that before, but the goal is to get blank by blank. What am I supposed to say? We are trying to get the what? The variable, yes, by itself. That's the goal, right? The goal here is to get the variable by itself. So let's go ahead here and understand that. The goal again, get C by itself. That's the goal. Get C by itself. So here's how we're going to handle this. There's a few different ways we can handle this. The way that I'm going to handle this is by dealing with positive numbers, because I know a lot of us here prefer dealing with positive numbers over negatives. So allow me to do this. If we want to get C by itself, let's go ahead and let's move that 6C. Everybody, right now we see minus 6C. If I wanted to get rid of that minus 6C and put it on the other side, remember that we have to perform the opposite operation. So what would we do to both sides here to move the 6C over? What should we do to move it over? If it's saying minus 6C right there, what should we do? Alvin, very close there. Not just adding 6, but adding 6. Alvin, finish it off there. Adding 6C to each side. Yeah, adding 6C to each side. Yes or no? Quick question, everybody. Can you combine 5 and 6C together? Can you combine those? Are those like terms? No, they're not. They are absolutely not. So what you're going to do here, it's going to cancel out right there. You're going to have yourself 23 equals 6C plus 5. Again, those aren't like terms. You can't have them. Just leave it as is. But I did that because guess what? It's all positive now. We're good. We're not going to deal with those nasty negatives. So now let's go ahead and get the C by itself. Everybody help me out. How do you get rid of that plus 5? How do you get rid of that plus 5? Thank you, Parmita. That's right. Subtract 5 from both sides, you lazy animals. Write out minus 5 on both sides. Don't just say minus 5. That's a lazy way to do it, man. Lazy way to do it. David, I'm looking at you. Sorry, got a cold. So minus 5 on both sides. Minus 5 on both sides. And so from there, booyah, that's going to be gone. And now we're ending up with 6C equals what? 18. That is 18. And then from there, everybody, again, we're just doing the opposite operations. Right now, what I see is I got a 6 multiplied with the C. What's the opposite of multiplying by 6? Divide by 6 on both sides. Divide by 6 on both sides. Booyah. And then we got C equals 3. 3 what? 3 what? 3 what? $3 for what? $3 for a hot dog? What? Yeah, $3 per pencil. Yeah. So the answer will be $3 per pencil. Boom. So my question here to y'all is this. Who here was able to do this problem intuitively? You know, without the equation. Who here was able to do it intuitively before I even worked it out? Okay, so look at that. A lot of people, right? A lot of people were here able to do that intuitively without much hesitation. So with that said, for those same people that were able to do it intuitively, were you at all, at any point, struggling to set up the actual formal equation? Did you struggle at all to set up the formal equation in terms of the 23 minus 6c equals 5? I see a slightly, I see a few no's. Okay, I like seeing the no's. But even if it was a yes slightly, what I want to make sure, and I'm hoping you're being honest, what we want to make sure we do here is, again, know how to represent English with math. That's the biggest, I would say, skill that you need to learn for arithmetic reasoning. So there we have it, my party people. Let me go ahead and just get my big old head out the way again. So take a screenshot if you need to, because what we're going to do next is I'm going to show you your notes one more time. Again, just reminding you about these key things. And then right on, Keisha, appreciate that. So Teo, we will be doing more problems like this, because what we're going to do now is I am going to present to us different questions. So we are going to identify the unknowns. Again, identify the question, list out those events so we can create an equation. The goal of today's class, everybody, is not N-O-T. It is not to solve the equations. That was yesterday. Today is strictly about setting them up. And so for those of y'all that want to try to find the answer right away, there's no glory in that today. There's no glory. Today's glory is going to come from setting up the equation. So I'm going to set up a timer for every question. Some questions, if I deem them to be a little more straightforward, maybe one step, I'm going to give you less time for those, about 1 minute, 15 seconds. If it's a question where I know it might take 2 or more steps, I will provide you with 2 minutes or more, just to be fair. So let me go ahead and get my timer here. And don't worry, it's going to be fair. And I want you to just do your best because, again, this is how we are going to grow. So let me go ahead and just... And there we go. Cool. So what we're going to do here, I'm going to get the timer up right there. And so now what we're going to do here is I'm going to go straight into this first question. And I'm going to have you set it up. Again, I'm not concerned about the answer. The answers will be there for anybody who wants to work ahead and try it out. But I expect everyone to have an equation set up. So when the time is up, I want everybody to type their equation into the chat box. I'm going to run through them real quick, show you the setup, highlight the answer, and move on. If you would like me to work out the problem for you, if you're in the All Access program, just take a picture of the problem, send it to me after. I'll work it out for you. But today's purpose, again, is setting it up. 3, 2, 1. Let's try this first one out. Go. Set it up. That's all I care about. I want you to represent the English with math. Don't reveal your answer yet. Wait till the timer's up. Wait till. So the thing is, we want to make sure and be careful about the use of the word total, because you can say, think about it like this. You can say this. I'm driving my car and let's say I'm going, some easy number, right? Let's say I'm going 10 miles an hour. If I'm driving 10 miles an hour and I go for 6 hours, so 10 miles an hour for 6 hours, what's the total distance that I drove? Everybody, in that case, am I actually adding? If I'm saying 10 miles an hour for 6 hours, finding total distance, am I supposed to add 10 plus 6 to get the total miles? No, right? I think we can think of that intuitively and say, yo, if we're doing 10 miles an hour for 6 hours, that's 10 times 6 hours to get 60, right? And so I want you to make sure that the word total, it doesn't it does actually mean addition, but the thing is multiplication is addition. It is addition. So think about the example that I just gave you. 10 miles per hour, 6 hours, that's 60 miles. If we do 10 times 6, that's the answer. But another way that you could represent this, everybody, another way that you could represent this would be 10 miles for the first hour, 10 for the second, 10 for the third, 10 for the fourth, 10 for the fifth, and 10 for the sixth hour. So 10 plus 10 plus 10 plus 10 plus 10 plus 10, 60 miles. So I do want you to understand that when you see the word total, but you're actually multiplying, multiplying is just a shortcut for addition. And that's where things can get somewhat confusing. So here's the key. Just to help you out, here's the key to keep things simple. If you see the word each, or per, or for every, ignore the word total. Ignore total because you're not really adding, you're multiplying. The word each, per, for every means take the shortcut and multiply. Cool with that? Yes or no? All right, sounds good. So let's go ahead and observe this real quick. Let's observe this. So again, first we're looking for right here, how much did each toy car cost? So cost of each toy. So we can say C or T or whatever we want. Now, here, 2. Well, what information are we given? Well, I'm seeing over here, we got 4 toy cars. Right here, 4 toy cars. And then it says the total cost, the results. So the total cost or the results, $8. So everybody, the word each, what operations does it always indicate, everybody? What does it always indicate? Yeah, so the word each would tell you that you're multiplying in this case. Okay, the word each tells you that you're multiplying. So if you have the cost of each toy, you multiply that with the number of toys to get the total cost. To get the total cost. And so in this case, what you should end up having is 4 toy cars times C dollars per toy equals $8 total dollars. In other words, your equation should have been 4 times whatever the variable you chose was equals 8. An alternate answer that I would have chosen would have been 8 divided by 4 equals C, or the answer. But the answer that you would have gotten after doing the math here would have been 2. But again, the primary equation that you should have come up with should have been 4 times whatever your variable is equals 8. So I'll take the question from Jose. What's up, boss? How are we feeling about this?
Kind of all over the place. But I get what you mean. Like I'm starting to see, but it's because I did both ways to be safe. Like I know it's more time. First I multiplied, and you know what I mean, that gives you 32. But then I was thinking dividing 4 does go into 8 twice. But then I was looking 4 cars, so I was like 1, 2, 3, 4, 5, 6, 7. But then I see how your other way too. Like at the same time they both had the answers, but then I see what you're doing. That's the thing that got me thrown off, is the setup.
I got you, Jose. So what it sounded like there, it sounded like you were, and I'm not saying this in a disrespectful way, it sounded like you were throwing spaghetti at the wall, hoping something would stick. When I heard you say, oh, I tried to do 8 times 4, then I saw 4 goes into 8. It sounds like you're not focusing on the meaning of the numbers. You're just focusing on the numbers. And you honestly will fail that way. We can't do that if we expect to be confident. So again, just trial and error and just guesswork and checking, that could work, could not work. It's not reliable. Again, Jose, I really implore you, focus on the meaning of the words. The word each, the cost of each toy, boom. Whatever that variable is, we need to multiply it with something to get the result. So you're saying, hey, man, the cost times the 4 gives you the 8. work backwards and divide by 4 to get 2. Boom. Doing it that way will guarantee a raise in confidence. But if you keep trying to throw spaghetti at the wall and then you get the right answer and you're like, whoo, got it right, there's no confidence behind it. And Jose, the one thing I want for you is confidence, man. You've been working your butt off on this. And I really want to, again, steer you away from trial and error. I want to steer you toward that confidence. Does that make a little sense, boss?
Yeah. Because at first I kind of understood it, but then like there was in the middle where that's where I got confused, and that's where I threw spaghetti. I was like, man, like I got stuck.
Yeah.
But like you said,
man. No, I absolutely understand, man. It can definitely feel that way. But at the end of the day, again, confidence comes from understanding there. So I'm going to take a question here from Sia, then Parmita, and then we're moving forward here. Go ahead, Sia. How you doing?
Hi, I'm good. Thank you. So I got it right, but I divided it. You said you could divide or times it?
Yeah. So remember that with the word each or per or for every, what you're doing is you can multiply that by the other piece to get the result. So again, you can multiply that by the piece to get the grand total of $8. Or we can work backwards and start with the result divided by that number that had each in it. So you can have it like this equals 4.
Okay, I just wanted to clarify that because I was kind of confused because I was like, how did I get it right? Because you kind of did it different and I kind of missed that step. But thank you.
Yeah, you can also do it like this: 8 divided by 4 equals C. That would also work.
Okay, thank you.
Hey, no worries. And so Parmita, go ahead, and then we're moving on to the next one. Try now.
There you go. Okay, can you hear me? Okay,
Yeah.
now can't you just like plug and chug? Because like you can plug and chug it. They're like 4 car toys, and then the total of it is $8. And then I'd be like, okay, what equals to 8?
Right,
And
but that would rely on your ability to know that you're supposed to be multiplying, right?
each, yeah.
Right. So if you're plugging in, you would have to have the understanding that each would be multiplying in this instance. And so if you already know that it's supposed to be multiplication, you're good anyway. Yeah, you're good either way. Yeah.
I just don't like setting it up. I just like to solve it.
Well, for me, then that's something definitely going to work on.
Yeah, I'm gonna work on it. I promise.
Sounds good. All right. So I want to go ahead and show y'all. Let me see here. Right there. So this one here, I'm going to give y'all 2 minutes to try to set up. So I'm going to give y'all 2 minutes here on this one. This is a bigger one for sure, obviously. I didn't want to do another straightforward one. I want to introduce you to, again, multi-step here. So go ahead, do your best, set it up. I may drop a hint about halfway through. Hey, welcome in, Colin. All right, so can't dig yourself out of a hole if you don't start digging, right? So 17, let me actually start from the beginning here and just walk us through what we got going on. So right here, straight to the question. She rented the bike for how many hours? So we're looking for hours. Is everybody cool with writing H? H for hours. I know some of us did C, some of us did X. Hey, it's great. It's up to you, man. Up to you. It's all good. But let's just be consistent here. I'm just going to use H, whatever. But look at the story here. The story here kind of really like lays it out for us. It really does lay it out for us because it says, look, $17 was the cost plus, everybody, the word plus means what? The word plus means add. Yeah, it's going to mean add. Sounds good. And so we start off with 17. We add on, and this is really important here, 7 per hour. Everybody, the word per, if we're trying to get to the results, what do we do with that? The word per, when we're trying to get to the result, what operation are we supposed to be doing to get to the final answer, the final thing? Multiply. Exactly. If we're trying to get to the total amount with the word per, we are multiplying. And so with that, that's where you'll take the $7 and you're going to multiply it by the number of hours. And everybody, once we add up all the costs, what was the result? The 38. Once we add everything up, the total result was, oh, we paid 38 bucks. And so that's how we can grab 17 plus 7h equals 38. And that was the answer. And again, I'm really focusing on the setup. I am not focusing on solving these equations. I'm focusing on the setups. Because again, if we can get the setups right, then we can start solving it. But we can't solve an equation that we can't set up. So we got to make sure we know how to set it up first. All right, got to make sure we know how to set it up. So in the camera there, so Jay, Parmita, Justin, Abraham, Max, Alec, you guys having a good time? Making sense? All right, sounds good. Sounds good. I know we have way more people here in the camera. I know we have more in the back there, but it's just showing me y'all 6 there. So with that said, boom, there's the setup. And once you actually complete it, if you want to copy this down, I'm just going to show you the way that it's going to look for the solution, but I am not going to explain myself. If you want an explanation, if you're in the All Access program, hit me up. First step. Done. All right. So I'll give you 5 seconds here. Give you 5 seconds to go ahead and there you go, David. Yeah, so you just pop back up in the camera. You had your camera off. Shut up. So with that, there it is. Go ahead and take a second to go ahead and screenshot that if you'd like to. Go ahead and screenshot that. There we go. All right. Boom. So everybody, yes or no? Are we feeling a little better on the setup? Are we feeling good about how to get the setup done? Yeah, I think David stepped away for a second. That's why he turned his camera off. Then he tried to play it off, saying that he was there the whole time. So he ain't gonna get me. So with that, there we are. You overthought it, Alex. It's all good, man. It's all good. Because again, with the practice, if you are trying, again, you can at least plug those holes up in your game. So let's go to the next one here. All right. So let's go ahead and okay, so let's try this one out. This one's going to be slightly tougher, but I definitely can trust you guys to get this right once we get it started. So I'm going to give you, again, 2 minutes. I'm going to give you just a little more time here, actually. About 2.5 minutes here. I'm going to give you all about 2.5 minutes for this one to set it up. Hey, right on. Right on, too. So congratulations, you got yourself kicked out. I'm kidding. So with that, here are the 2 different setups that you could have. You could have had this right here. You could have had, you could have had 371 equals, and you could have had 9x plus 29. And then the other setup that you could have had was something like this: 9x equals 371 minus 29. Either one of those would have worked. All right, either one of those would have worked. But I hope you guys notice here that they're both the same thing here. Everybody, just take a look. Everybody, look, if you go ahead and subtract 29 from both sides in this first one, when you subtract 29 from both sides, that's what you get. You're going to have this minus 29 and then the 9x by itself. So everybody, do you see how if you have either one of these setups, they would both be the same? Most of everybody who got it correct had this one here, but I'm going to show you how to get it done. Don't worry. So again, if you're asking me if these questions are going to look exactly like the test, you're asking the wrong question. Again, if we focus on understanding how we can set these up, it doesn't matter what they present to you, and how they present it to you doesn't matter. You can still get it right. So here we go, everybody. So the question is asking us to find the number of students, and that's going to be X or C. I wouldn't use S because that looks like a 5. So I would just say, X or Y or C or M or K or whatever. But there it is. We're looking for the number of students. Okay, and specifically on the buses. On the buses. So it's good to clarify that. Nice and easy. Now, number 2, let's go ahead and collect our information so we can tell a story. We want to tell a story. So what does the story say here? The story says the field trip, 29 students rode in cars. Okay. So 29 students in cars. Then next it says, okay, the rest filled 9 buses. The rest filled 9 buses. So I'll write that in blue here. And now, do they tell us how many students were in each bus? Do they tell us, everybody? A lot of y'all are saying no. They do. They just didn't give us a number for it, but they did. How many students were in each bus, everybody? What's the letter? What's the letter? B or X? Yeah, right there. Number of students in each bus, right here. How many students were in each bus? So let me clarify this actually to make it a little simpler, a little easier to see, because I think it deserves that for sure. The number of students, whoops, you didn't see those other questions. In each bus, right here. In each bus. Okay, the number of students in each bus is what we're looking for. So if we have 9 buses, everybody, what are we supposed to do with the 9 buses and the X or the B, the number of students in each bus? What are we supposed to be doing with the 9 buses and the X students in each bus? What did we say if we see the word each to get the results? We do what? We multiply. Remember, when we're working forward to find the total number, that is multiplication. And so 9 buses, we don't know how many were in each bus, but we know that we will multiply those together to get the total students in the buses, in all the buses. Yes or no, everybody? Does that make sense? Again, to work forward to get the total, we multiply. Again, I got to make sure we drive that point home. So yes or no, does that make sense there? Yes or no, does that make sense? I got about a dozen or 2 people saying yes, but we do have 140 people here today. So I want to make sure that makes sense here. Come on, yes or no? And you can say no. You can absolutely say no. It's all good. All right, sounds good. So again, if you said no, thank you for being honest. Remember, if you want to get the result, whenever you see the word each, you multiply that number with the other one to get the result. The result being the total, how many you have total in all these buses. So here we have it like this. Students in cars. So total car riders plus, and let me take off this timer here so I have more space. Sorry guys, 1 second. Goodbye. All right, so the total car riders plus the total bus riders equals everybody what? And I took my face away and not even the timer, I'm done. So the total car riders plus the total bus riders is supposed to equal what, everybody? What is it supposed to equal in this problem? If you add up all the kids that took cars, all the kids that took buses, it's supposed to equal what? 371, exactly. It's supposed to equal 371 students. 371. Boom, right there. 371 total students. I'm going to scroll down just a little bit. Total riders. And so there it is, guys. There it is. I really want you guys to make sense out of this. I want common sense to really take over here. And then work to make that common sense math. All right. So that's what we're trying to do. So everybody, how many total car riders did we have? 29, correct. Then from here, what we're going to do is we're going to add up that with the total bus riders. But we don't have a number for the total bus riders, but what we know is that we have 9 buses and X in each bus. So what should we write to represent the total bus riders? What should we write to represent the total bus? Right, yeah, 9B or 9X or 9C or 9K, whatever letter you use to represent the students in each bus, it's on you. That's all good. You got it. But it's going to be 9 times that variable. It's going to be 9 times that variable. And so the grand total, once you add everything up, is 371. And there we go. And there's your equation. So let's go and ask ourselves here, does this equation make sense? This is what you want to do. Before you move on, does this equation make sense? So if we have 29 students in the cars plus the 9 students or the 9 buses times each student or all the students in each bus, multiply it together, you get the total, add all this together, and you get 371. Cool. We're good. We're good. And so then we're set. And so now we're going to solve this. And, to solve this, I'm going to take it very quickly here. What you would do is subtract 29. So to solve this, you would go ahead, subtract 29 from both sides. And let me actually make this a lot smaller so I have more space here. I know my head is definitely blocking some of that. I got y'all. So I'm going to just move that aside just a little bit there. I'm going to solve this real quick for y'all. So you subtract 29 on both sides. Here's mental math at work, everybody. 371 minus 29. I know a lot of y'all would be like, we got to borrow 1. No, you don't. So if you want to subtract 29, subtract 30. Then add 1 back because you subtracted 1 too many. So 371 minus 30, that's 341. Add that 1 back, 342. All good. All good. 342. Nice and easy. And then bam, now what we're going to do is divide both sides by 9 and you're all set. And you're all set. Booyah. So divide both sides by 9. Done. And so here we go. 9 going into 342. Well, I know that 9 can definitely go into 360, 40 times, but it's going to be 2 less than that, 18 less than that. So that's going to be 38. If my mental math is correct, answer is 38. And if you're sitting here thinking that that's impossible for you to achieve, no, it's not. No, it's not. Who here was able to follow along with the mental math that I just did? Kev, right on. Who else? Right on. Again, like these are the people that show up to class consistently, have downloaded mental math apps and have been trying. I'm telling you guys, if you want to save time on the ASVAB, get to step in on that mental math. Take it seriously. 5 minutes a day is enough. It'll get you there. It'll get you there. The answer here is B38. It is B38. And also, because you guys keep asking in the chat box, I know you're trying to be slick asking me privately. Here's the link to the All Access program. If you're curious about it, there's the link to the All Access program. I'll let you check it out on your own. Prices are low. It includes a lot of great stuff, including my advice all the way through. So if you're interested in that, I'm going to leave that there just right now, but I don't want to take any time away from y'all. This is your time, not for me to talk about the program. So with that, there it is. Again, if you want to ask me about it after class, I'll leave my number. So with that, let's go ahead and try this next one here. So I'm not going to show this next one. This one's too tough. We're mixing in geometry here, and I don't want to trip anybody up because we're having a great time right now. So I'm going to go ahead. Ooh, let's check this one out. I really want to do this one. This is what I really wanted to get to today. And because it's unique, it's really unique. So let me give you guys, again, the 2-minute marker here. Let's go. And let me put the timer up. Whoops, timer is back up. Abracadabra. Thank you. All right. Cool. So this is the only time, or this is an example of an exception where you do want to kind of just sort through and just look at what the problem's about. How many what? And you can just, just quickly read through. On Tuesday, Eugene bought 4 CDs, half of the CDs. On Thursday, there were only 13. Okay, so we're talking about CDs. So right there, step 1, how many CDs did he have on Monday? So number of CDs on Monday. That's what we're looking for. Everybody, what letter do we want to use for Monday? Cool. Yeah, Monday. Yeah. Nice. Cool. Sweet. Nice and easy. Perfect. So with that said, my party people, let's go ahead and let's tell a story. Follow along. Watch this. This is how beautiful this can be. So in the beginning of the story here, what we're going to see here is on Tuesday, we bought 4 CDs. So everybody, let me ask you this. Okay, let me ask you this. If we bought 4 CDs on Tuesday, how many CDs do we have now? Why are you guys putting up numbers? This is why it's so important to know how to follow the story. Everybody, what day comes before Tuesday? Everybody, what day comes before Tuesday? Monday. Okay, cool. Everybody, how many CDs do we have on Monday? It's not a number. So far, it is not a number. How many CDs do we have on Monday? M. Right there. We just said it. We are looking for the number of CDs that we have on Monday. We don't know how many CDs that is, but we represent it with a variable, with a letter. That's what we're doing right now. We don't know how many there are on Monday. That's what we're looking for. That's what we're going to figure out. We're going to sort this thing out. But for right now, the placeholder is M. Everybody see how variables work now? A variable works to define a number that you don't know yet. That's all it is. You're using it as a placeholder. So on Monday, we got M. So right here, watch this, everybody. On Monday, we've got M CDs. On Tuesday, everybody, how many CDs do we have? How many CDs do we have on Tuesday? We do not have 4 CDs on Tuesday, everybody. Think about it like this, everybody. Imagine, for example, if on Monday I actually had, let's say, 11. Everybody, if on Monday I had 11 CDs and on Tuesday I added 4 more. Pay attention one more time. If on Monday I had 11 CDs and on Tuesday I added 4 more, how many CDs do I now have on Tuesday? We got 15 now, right? What do? We added Monday and Tuesday. So I want to ask again, and now y'all starting to get it in the chat box there. On Tuesday, if we add 4 more CDs and we have M on Monday, and on Tuesday we added 4 more, how many do we have on Tuesday now? M plus 4. We start with Monday CDs and we add 4. M plus 4. M plus 4. Right here, plus 4. Everybody, does that make sense? On Tuesday, if we bought 4 more CDs, we just add 4 CDs to Monday. So Monday is M, Tuesday is M plus 4. Now let's go ahead and look at what happened on Wednesday. Everybody, what happens on Wednesday? What does the story say happens on Wednesday? Does it say 2 destroyed or half were destroyed? Half of those CDs got destroyed. And it's okay because half of them were probably Kelly Clarkson and Avril Lavigne, and that's quite okay with me. But here we go. It says Wednesday, half of all the CDs that he had were destroyed. If the homies would have found it, wouldn't have been a good time. So with that, I'm not talking about myself. So here we go. Wednesday, half were destroyed. Half were destroyed. So with that said, how many did we have on Tuesday? We had M plus 4 on Tuesday. And then half of them got destroyed. So everybody, is it safe to say that we will take the M plus 4, that entire bunch, and divide the whole thing by 2? Yeah, that's right. Oh, Alec, you got it, man. Yeah. We're taking the whole thing over 2. It's the whole thing over 2. And so boom, we'll take, again, we started with M on Monday. We added 4. This is Tuesday now. On Wednesday, we cut that all in half. Whatever this adds up to, We divide it by 2 because we're cutting it in half. And so from there, this is going to end up as 13 on Thursday. This is Thursday right there. That's what we have left. 13 left. And so that's the idea. If you take half of them away, boom, you got 13 left. And so your equation should be m plus 4 over 2 equals 13. M plus 4 over 2 equals 13. So does that setup make sense, everybody, in terms of how we followed the story from the beginning all the way until the conclusion, the 13 being the conclusion? But we have to be able to look at these problems from the lens of storytelling. We have to be able to tell a story, because that's how we will eventually be able to translate the English into math quickly and confidently, so that we can compute and have a good time and be sure that we have the correct answer. Remember, that instinct, that intuition can only take you so far by itself. There are going to be times where there's more than 1 step, 2 steps. This one is 3 steps. You got to make sure you know what you're doing here. Got to make sure you know what you're doing. So with that, let me let Alvin back in. I think he got too excited and exited the laptop or exited the Zoom class. So with that, all right. If we're going to solve something like this, then I'm going to go quickly because I want to try to do one more problem here before 8 o'clock rolls around. So if we're going to solve this, the first step that we're going to do is get rid of that 2 here. So we'll multiply by 2 on both sides. Cancels out. We're left with m plus 4 equals 26. Then we subtract 2 on both sides, and we end up getting 22 CDs on Monday. D. Answer is D. There's a worksheet with a bunch of problems like this for sure, Sammy. Yep, there's a worksheet with about 60 of these problems on this. Oh, not Sammy, excuse me, not Sammy, my bad. Lewis. Yeah, Lewis. There's a ton of these questions in the math bootcamp. Yeah. So with that, I'm gonna take some questions here real quick. And go ahead, iPhone.
I was just wondering, does this have to do with the mechanical section?
So the mechanical comprehension section, no, not exactly. I mean, there are always mathematical components in those engineering sections, but I wouldn't count on this solely to help you there.
Okay, thank you.
No worries. Thanks for asking. Israel, what's going on, boss?
No, you just fixed it right now because you're the -2 from both sides.
Oh yeah,
it was supposed to be.
Yeah, appreciate that, man.
Yeah.
My brain, my hand wrote 2, but my brain did 4 because it's still the right answer. It's still 22. But yeah, that was my fault. Quick little mental error there. But yeah, there it is. So yeah, it still would have been the right answer, 22. I just wrote -2 accidentally instead of -4. But yeah, still there. So do we have a mechanical section? No, we're working on that for sure. We're working on that for sure. So here we go. We're gonna go ahead and I'm gonna show you guys one more problem here. Hey, no worries. Yeah, Steph Roy, that's Stephanie, yeah. Okay, guys, come on now. Maturity here. So I'm going to show you one more, and then right there. So I'm going to give you all this last one here. So we're going to talk about this bozo named Mr. Duran. So go ahead, try this problem out, take 2 minutes. And then I'm going to show you the setup, and we are going to end class at that time. So let me go ahead here and start that timer. Let's go. Let's get it, guys. Trust yourself. I knew this always happens. Every time that we go to a harder problem and then we come back to what was harder before, y'all always get it right. Y'all always get it right, man. So the setup should have looked something like this. 9m plus 45 equals 153. You also could have had 45 plus 9m equals 153. You also could have had this as well. You also could have had 9m equals 108. All three of those setups would have worked. And y'all just kicked some butt today, man. I'm going to go ahead and give y'all the mic because I'm going to record this because you already know when we have a great class like this, we got to hit it with a yurt. So let me go ahead and make sure I'm actually recording this time. But man, it always happens. I'm going to go ahead and make sure I am quietly letting the beast out of the cage. How was that today, guys?
Excellent.
So sorry to any parents out there who are watching their kids for the first time do these classes, but that's the excitement that we love seeing. So with that said, everybody, you guys are awesome. If you need me to help you, set this up and work on this, if you're in the All Access program, just shoot me a text. If you have an iPhone, I can go ahead and voice message you back, or actually, I might just create a quick video for this one and just send it back out to y'all. Again, that's only for those in the All Access program.